sometimes there is a little bit of a nuance in English language, and then we have to start again, right? So we have to just do it again. This appears to be an interesting one. So use the following data to draw a time series. So we have the time series that we discussed over time. Use the graph to see what might be determined about the patient's temperature from data that is collected every hour in the clinic. Okay. Draw a line graph, choose the correct graph below. Okay, so first we have to identify what we have on the x-axis and what we have on the y-axis. Of course, all of them have time. Time is the independent variable, and temperature is the dependent variable. So the first point will be 6 a.m., 97.1 degrees. 6 a.m., 97.1. So this is no discussion. This goes away. So obviously A is a potential, C is a potential. Let's continue. I will jump to the last one. For 12 is 101.9. But look what happens here. 12 is 97. So by simply comparing these three graphs, we know that A is the correct answer. Okay. What might be determined about the temperature of this patient in the clinic over their 6-hour time frame? What will you say? The temperature has steadily risen all morning. The patient is likely getting worse. There are no significant changes in the temperature from 97 to 102. There are no significant changes. The temperature has steadily declined. The temperature has steadily risen, then started to decline. So which one are we considering?
I think it's A because it keeps rising.
Yes. That's how the doctors and nurses look at. That's how they look at the patients in the hospital. Okay. Anything else? Let's choose one more and move on to 2.4. Unless you want more.
Question 8.
Okay, so let's take a look at 8. Quantitative data provide numerical measures that can be counted. Quantitative data can be discrete or continuous. Which of the following statistical displays would be appropriate for organizing quantitative data? Stem and leaf plot, we just did that. And dot plots. Dot plots are not for continuous data. Dot plots are only for number of children, number of cars, so they're not for continuous. Frequency distributions and histograms. That is true. I can determine frequency distributions and histograms. Line graphs and time series graphs, yes, all of the above. So stem and leaf, yes, but the dot plots are just for discrete, not for continuous. I cannot use dot plots for continuous. But it says discrete or continuous. Line graphs, time series, yes. Frequency distribution, yes. Histograms, yes. So I'm tempted to, and I think the correct answer is all of the above. Although the dot plots are specific for discrete, never for continuous. Any questions? Is there anything else we want from 2.3?
Nope, I think we can move on to 2.4.
Okay, do we have enough for being, finishing this chapter 2.2 and 2.3 for now for Monday? Would you agree? Okay, then. So let's move on to the last section of this chapter. And please don't forget also the chapter 2 quiz. Okay, so let's look at 2.4. Last one from chapter 2, so we can start chapter 3. Identify which of these methods can be used to okay, I did not talk about this, so I have to stop for a moment. Stop sharing, and talk about something called data manipulation, graphs that distort information, and so on and so forth. And I did print out, let me see where it is. I did print out one, give me 1 second. I have one graph to show you. If I can't find it, we can just go directly to problems. I don't want to waste your time. I got it. Here it is. And I will put this with the notes. So here's what is called misrepresentation of data using graphs. I hope you can see 1950 here and 2000. And 68, 70, 72, 74, and so on and so forth. So this is the life expectancy in years. And it looks like, wow, from 68 to 77, it just went, phew. But actually, from 68 to 77 is not that huge of a increase in the life expectancy in years. So we can make it look like as if it's extremely acute and very important, but it's actually not that big of a deal. So that's how sometimes we can use graphs to misrepresent data. We have others like not just the graphical misrepresentation, but if you remember, we looked at the pie chart. And the pie chart was very nice. It would tell us, based on the angle, central angle, what really happens, which one is more important, and which one has a higher percentage. For example, I could have something like this. And I could say this is 70%, this is 20, and this is 10, as an example. Of course, I have to have 100%, 70, 10, and 20. So it's very nice and clear that this is the biggest chunk and these two are smaller. But if we're using a so-called 3D pie chart, look what's going to happen here. You cannot really see if it's a 3D pie chart. You cannot really see which one is bigger. This kind of appear equally distributed. This kind of looks to me like 33%, 33%, and 33%, which is not the case. So that's another a graph or a pie chart or a chart that distorts the information. Okay? So that was the end really of chapter 2. So now let me share my screen and we can work on any problem. So identify which of these methods can be used to distort a bar graph. Select all that apply. Stretching the vertical scale. Yeah. That's the example I just gave you. We stretched here, back for a second. We stretched the vertical scale. And by stretching the vertical scale, I really show that this is huge, a huge difference. But actually it's not that big. So that is a way of distorting the information and impressing people with it. Making the width of the bars proportional to their height. Yeah. Starting the vertical axis at a point other than the origin. Yes, that's very possible. That could distort the information. So I'm making the width of the bars proportional to the height. Yeah, that is a possibility. All, to me, they're all possible. I don't know. Let's see what they accept. All of them. Let's see how many problems we have here. Okay, so let's choose whatever you want.
Question 3.
Number 3. Good. The following graph shows the average price of a movie ticket for the years 2009 and 2010. Complete parts A and B below. Okay. So I just want to see it better. Okay. Draw a bar graph that shows the entire scale from 0 to 8. Choose the correct graph below. So, which is the average price? Okay, the average price of a movie ticket. 2009, the average was 7.23, and in 2010, the average was a little bit higher, but the scale is stretched. I mean, the difference from 7.23 and 7.74 is not that big. This looks like it's double. So the green, the piece of the green is something like here, and this is like 3 times as much. You understand that if I want to fit this in this purple bar, I could fit 3 of those. So this looks like 7.74 is 3 times as much of 7.23. So this should be like $21 or $23, the way it is presented here. So obviously this is distorted because the horizontal axis, the price, is so stretched that it appears like 7.23. As I said, it's like 3 times smaller. So this cannot work. This cannot work because they are the same. That doesn't make any sense. Now, let's see what happens here. So these are the potential ones. Obviously, this one is a mistake because 7.74 and 7.23 have nothing to do with what we have here, right? In the sense that this appears that 7.23 is bigger than 7.74. Makes no sense. This is the correct graph. 7.23 and 7.74 are not such a big difference. And this is shown here, not in any of these. Do we understand how to read this graph? Okay. So I guess there is a part B. Where is part B? Oh, continue. Does the new graph give a different impression? Explain. Choose the correct answer below. No. So the no ones I can disregard, right? Yes, the price difference appears more reasonable in the new graph. Yes, the price difference appears more reasonable in the old graph. So the difference is small. It's not 3 times as much. This is completely confusing and it does not show the truth. Very good. Good pick.
Question 5.
Question 5. Let's take a look at 5. The graph to the right uses cylinders to represent barrels of oil consumed by 2 countries. Okay. So again, I'm looking, I did not finish reading it, but country A, it's 18.9, and country B is 5.5. Well, obviously this is terribly confusing because this tiny 5, right, how many 5s will fit in here? Definitely more than 3. It's like 50 of these 5.5 will fit in this humongous red cylinder. If you want to put this in here, you're going to probably fit, I don't know, 10. So does the graph distort the data? or does it depict the data fairly? No, it does not depict it fairly. Why or why not? If the graph distorts the data, construct a graph that depicts the data fairly. Okay. Does the graph distort the data? Why or why not? Yes, because 3D objects always distort the data in graphs. Okay. No, because no. Yes, because the graph incorrectly uses objects of volume. So yes. So I would say because 3D objects always distort the data in graphs. I would agree with that. Definitely, I would not use no, because the graph is technically correct. No. Even if it were correct, the tiny blue cylinder is, I think it fits more than 10 in the red one. So the red one should be 55, not 18.9. No, because the proportions are accurate. No, the proportions, no. Yes, because the graph incorrectly uses objects of volume to. So that's okay. Some graphs are bad in the sense that they contain errors, and some are bad because they are technically correct but misleading. Drawings of objects called pictographs are often misleading. Examine the graph of errors and to determine whether objects of area or volume are used. Yes, are actually one-dimensional. So yes, they're using, because the graph incorrectly uses objects of volume to represent. I wouldn't say because it uses the volume. I would say that there is no scale. There is no correct scale here. I would say, well, obviously the nose, because the proportions are accurate. I don't think proportions are accurate because I think that this fits in here way more than just 3 times. No, because the graph is technically correct. I don't think the graph is technically correct. So be careful with these problems because you really have to analyze it. In general, 3D objects distort, but maybe I wouldn't say always. Maybe that is not always. Yes, because the graph incorrectly uses objects of volume. I think that it fits. So the 5.5, I think it fits more than 5 of those in here. So this will not be, the scale will not be correct. I will see what they want. Incorrect uses objects. Yes, so the scale is incorrect. Okay, let's see. If the graph does not depict the data fairly, which graph below does? So I will have to divide. I'm going to divide right now 18.9 by 5.5. And that is 3 times as much, as I was already saying. So 3 times as much, it should be okay. So the 18, so country A, country B. This is nonsense. Country A and B. So this is the 18, and it's 3 times as much, and this is 5.5. This one is not 3 times as much. So this one is 10 times as much as this. So this is indeed 3 times as much. I accept that. Okay. We still have a few more minutes to finish this chapter.